This video will cover how to declare and use swing components in a JFrame, JApplet, or applet interface. Now before we do this, there are some things we have to import. Here's an example of importing different packages for a color object, a container, a JFrame, or a JOptionPane. As an alternative to importing components one at a time, you can import an entire package with a wildcard, which is the asterisk like so. Import javax.swing.asterisk, import java.auth.asterisk, and import java.auth.event.asterisk for event handlers from the Abstract Windows Toolkit and Swing packages. Before we get into each component, let's cover some preliminaries. One of the first preliminaries we need to cover is getting the content pane. Before adding any Swing components to a JFrame or JApplet, we must get the content pane by calling the method getContentPane. This is something like grabbing the device context with GDI methods in C++ MFC programming. Doing this gives us a pointer or handle to the JFrame or JApplet's background, so we can add components to it or draw objects on it. Then we can add items with the add method. For example, if I were coding a JApplet or applet project from scratch in a text editor, inside the init method I would want to get the content pane with the method getContentPane, and I would assign the return value to a container object. I could then use this instance of a container object to add components with the add method. Alternatively, if I were coding a project with NetBeans, it does things a little bit differently. In this example, NetBeans just simply calls the method getContentPane and right after calls the add function to add each component. It's able to do this using the this pointer, which points to the current object, in this case the JFrame, JApplet, or applet. Once we get the content pane as a pointer to the background, we also need to specify a layout manager. You can think of layout managers as different types of word wrap for Java components. In the same way that the word wrap feature wraps characters of text around to the next line in a word processor, layout managers wrap swing components around the visible area of a JFrame or JApplet. All layout managers derive from the Abstract Windows Toolkit package. Previously, we did an entire video on layout managers and how to implement them in your projects. So if you need to know more about them, you may wish to watch that video before watching the rest of this video on swing components. However, to lessen the amount of time that this video consumes, we're not going to repeat that information here. So again, if you need to know more, watch the video on layout managers. Having discussed some of the preliminaries, let's review some of the Abstract Windows Toolkit and Swing components you can add to your JFrame and JApplet and applet Java projects and applications. The first component we're going to look at is the font. The font class object represents fonts in Java Swing applications. For example, here we're declaring a font called Big Font to be Times Roman, bold, and 28 point. And then we're going to assign this font to a JLabel that we've instantiated called Message with the function setFont. So we simply call message.setFont and pass in the font object we instantiated previously, Big Font. The next Swing component we'll examine is the JLabel. JLabels can display a single line of text and do not take input, they only do output. Here in this example, we're declaring a JLabel called title and message1 and message2. Notice that in the constructor, if we want to, we can set the default text property on the JLabel. Otherwise, we can also set it with the function setText later after we've instantiated it. Let's examine how this looks in code. First, for this project, we need to import two packages. The Swing package, the entire package, because we're using the asterisk or the wildcard, and the Java Abstract Windows Toolkit or AWT package, again using the wildcard or asterisk. Once we import these packages, we're going to extend JApplet. So this is going to be a JApplet project, and inside of our class, we're going to declare 3 JLabels. The first JLabel we declare is going to use the constructor in this case to give it the text value Java fonts example. The remaining 2 JLabels don't do that. They just create a new JLabel, and we're going to set their text property later with the method or function setText. After we do this, we're going to instantiate 3 font objects. So big font, medium font, and small font. We build them with the new keyword. And when we do this, notice the parameters are the argument list. In this case, it takes the font face, Comic, Sans MS, Trebuchet MS, and Arial. The next argument, separated by a comma, is in this case bold, italic, or plain off the font object itself. And then the third and last argument is the point size, 32, 24, and 18 respectively. Remember that every JApplet applet has an init method, and it starts automatically when you load the JApplet or applet. So inside the init method, we need to do what's required, in this case get the content pane, and apply a layout manager. Once we do that, we can then set the font on our 3 JLabels with the setFont function. So on title, message1, and message2, we're setting big font, medium font, and small font. We set the text property here, and then finally we're going to add our 3 JLabels onto the JApplet background. So let's run this and see what it looks like in this example. Okay, and here's what it looks like. In this case, we'll resize that a little bit. JFont's example, and if you look, that was in, we'll scroll up here a little bit so you can see the font. Here's the first JLabel, right? That's the title. And notice it's Comic Sans MS 32 point. The next one was Trebuchet MS, and it's italic, and it was 24 point. Heed the Song of the Hybrids. And the last one was smaller. It was Arial and plain, and it was only 18 point. All of this has happened before and will happen again. And notice the order that the JLabels were added, and that's the order in which they appear. So hopefully that'll kind of give you an idea of how those two components work in code. Adding JLabels the NetBeans way is pretty straightforward. Notice if I wanted to, I could add a new JPanel form, JFrame form. In this case, we'll do, let's say, JApplet. So if I go to Swing GUI Forms, here's a JApplet form. Next, and we'll call this test GUI IDE or something like that. Alright, when I do that, notice that I have a source view and a design view. And notice here I'm extending JApplet. Notice that the init method here, the built-in init method turns around and calls another function, initComponents. So to add JLabels, all I have to do is go under Swing Controls. I'll just drag one on here. And I'm going to set the Layout Manager, right-click, Set Layout to Null Layout. Alright. Then I'm going to add a second JLabel. Alright, so that declares or instantiates 2 JLabels. I could modify the variable name under the Code tab. Call that title. And I could call this one message, or message1. Okay. Now I could go to the Properties tab, and basically calling the setText method, I can modify the text, or utilizing the constructor. I'll call this one JLabelFun. And I'll adjust the size property here instead of having to call the method setBound. So it's writing the code for me, and I'll go show you that. In just a moment. Let's see here. Now I'm going to just simply say what once was will be again, or something to that effect. And I'll just kind of adjust the size here. Okay. Alright, so that's adding the JLabels, and when I do that, notice that it wrote the code here. In this case, it declared 2 JLabel objects, and if I open the code fold, these are little code folds here. You can click on the plus or minus sign to open or close them. Let me go find the initComponents code fold, which is, let's see, init, right here to, there you go, generated code. So in initComponents, notice here is instantiating or building the JLabels, getting the content pane, and setting the properties on those items using setBounds. Alright, so what if I want to modify the font? Let's do that, and we will font. I'm going to modify this or change this to some other font. I don't know, Calibri maybe. Okay, and over here, let's modify the font here. So again, I'm going to go here under Properties and select a different font. Alright, so we'll do that. And when I do this, I'm going to go back to the Source tab. And let me go back into my code fold here. The generated code, to click on the little plus there. Okay, and so when I do this, notice that it's building a new font object on the fly and passing it in as a parameter or argument. So there's Calibri, there's Zurich. It's actually writing or generating the code for me. So kind of cool. Either way, whether you code from scratch or whether you use NetBeans, it's utilizing the same functions, but it handles things a little bit differently. The next component we'll examine from the Swing package is the ButtonGroup. ButtonGroup objects combine JRadioButtons together into a group so that only one radio button at a time may be selected. For example, here I'm instantiating a new ButtonGroup object called MainBatteryGroup. When I do this, I'm then going to build 2 JRadioButtons, and I'm going to add them to the ButtonGroup with the add method, calling it on the name of the ButtonGroup. This, of course, brings us to the next component, a JRadioButton. JRadioButton objects are elliptical buttons that can be placed on JFrame and JApplet forms, dialogues, and graphical interfaces. They usually share a button group so that only one JRadioButton within the button group can be selected at a time. Some useful methods for JRadioButtons are setSelected, which selects the radio button, isSelected, which returns true if the radio button is selected, and setText, which sets the caption for the radio button. While we're on the topic, let's look at JButtons. JButton objects are standard rectangular buttons that can be placed on JFrame and JAPPLET forms, dialogues, and graphical interfaces. Some useful methods for JButtons are setEnabled, which enables and disables a JButton, and setText, which sets the caption for the JButton. Here in this example, we need to import from three packages: the Swing package, the Abstract Windows Toolkit package, and event for our event handler ActionListener. We're extending JApplet, so it's going to be a JApplet interface, and we're implementing the event handler ActionListener. So we have two JLabels here, in this case a title object, main batteries, and then one that we'll use to display text in for status. We have a JButton here, in this case called test. Then we are going to build and instantiate a new button group object, and 4 radio buttons here: arm, disarm, deploy, and abort. Inside of the init method, we have to do the required functions of getting the content pane and setting the layout, in this case to null. Once we do this, we're going to add our JRadioButtons to our button group so that only one can be clicked at a time. If we didn't do this, then we'd be able to select more than one at a time. And most of the time with radio buttons, that's not what you want, so you'll need to add them to a button group. So we're doing this here. We're going to set disarm as the default selection. So in the init method, that will be the radio button that is selected when our JApplet loads. And we're going to add ActionListener to it, in this case because we want to listen, and when that particular radio button is clicked, we're going to go handle it in action performed. And then we're going to add it, in this case, to bTest when we click on the test button, just a J button, okay? And this plain old J button over here will simply get the selected radio button, and will display different text based on which one is selected. So ActionListener being added to 2 items. We're going to go down and just set some of the properties. Since we're using null layout, we need to use setBounds and specify the x and the y and the width and the height of each of our objects. And so we're going to add them in. In this case, there's our label and our radio buttons and our normal J button and our status JLabel there. Inside of action performed, what's going to happen? Well, let's get the object source so we can figure out exactly what got clicked when that event is triggered. And once we figure out where that action event came from, if it comes from RBArm, we're going to fire a JOptionPane off saying arming. On the other hand, if the source was the test button, that normal J button, we're just going to change the status text to either armed, disarmed, deployed, or aborted, depending on whether or not those radio buttons happen to be selected by calling the method isSelected, which will return a Boolean value, true or false, and we can plug that into our if statement. So again, to see how all this works, let's run the program. And I'm going to move it over here in the middle so you can see and just resize it a little bit. Okay. And notice that disarm is the default, and that's the reason being because that was selected. We said setSelected true, so it's the default selected button. Now, if I click these, notice that when I click one, it deselects any of the others. I can only click one at a time. And once again, the reason for that is because we created a button group, and then we added those radio buttons to the button group. Okay. And if I were to click test, notice that it says aborted, deployed, or disarmed, because I added ActionListener to our JButton test, and then every time an action performed, if the source happens to be test, based on which radio button is selected, it's going to display different text in the JLabel. And finally, if I click here, notice that it fires off a JOptionPane because it detected the source. In this case, instead of being the J button bTest, it was the radio button RBArm. So I can use that there. And then again, if I were to click on the J button test, it says armed. In the NetBeans IDE, I'm here in Design View, and now I'm just going to add these graphically. So a button group, I'll just select it, drag it on there, and I'm going to go to the Code tab and we'll rename it. Call it the main button group. And now I'm just going to go over here and I'm going to grab some J buttons, in this case. So radio button, radio button, radio button, radio button, add those on. And I'm going to go ahead and grab a normal J button here, just a square button. And I can modify the text property on any of these if I go to the property sheet. Notice here, I can set the text on, disarm, alright, whatever I want to set it to there. And then I can hold down Control if I want to, and I can select all 4 of these radio buttons. And if I do, I can come up here and in one click, I can make them all share the same button group. Okay. Now if I select any one of them, it'll show their button group in this case. Notice there's like a little line there showing that they're all in a button group. And you can see the code that NetBeans created for me. Here it instantiated and declared the objects. Well, declared them. Let me go to init components. Here it's instantiating the objects and then setting the properties on them and adding them to the appropriate button group. In addition to JRadioButtons and JButtons, a third type of button is a JCheckBox. JCheckBox objects are selectable buttons that can be placed on JFrame and JAPPLET forms, dialogs, and graphical interfaces. Some useful methods for JCheckBox objects are setSelected, which selects the checkbox, isSelected, which returns true if the checkbox is selected, and setText, which sets the caption for the checkbox. This is similar to the previous example, but instead of JButtons and JRadioButtons, we're using JCheckBoxes with a JButton. Again, I'm importing the same 3 packages, Swing, Abstract Windows Toolkit, and Auth Event, so that I can implement ActionListener. It's a JApplet. Notice I have 2 JLabels, one's the title, one's the status, which will be changed based on which checkbox is selected. I also have my test button here, my old JButton test button, as we did before. Here I am instantiating 4 checkboxes, and in the constructor we're passing in the text property. Alternatively, we could set it with setText. Create warp bubble, collapse warp bubble, augment warp bubble, diminish warp bubble. Inside the init method, we're doing what's required. We have to get the content pane. I'm setting the layout to my favorite, null, and then therefore I have to use setBounds to specify the x, the y, the width, and the height of each component. I'm adding ActionListener to what I need to add ActionListener to. In this case, my JButton test, when I click it, I have to listen for that event, and just one of the checkboxes here, which is in this case collapse. Also, the default box that will be selected is going to be the create checkbox. Notice that setSelected is true there. So we, in this case, add all the components to our content pane so that it will be added to the JApplet background. And we set the position and the width and the height. And then finally, here's our label. And we're simply going to draw a border around our label and center the text that's created inside of it. Well, because we're implementing ActionListener, we have to also include ActionPerformed, our event handler method, which takes an action event. We're going to get the source of it, and when we do, in this case, if the checkbox collapse is selected, we're going to fire off a JAptionPane, simply giving a warning message. On the other hand, if the object source happens to be our JButton bTest, and we call getSource, then we're simply going to display a different message in our JLabel text there based on which checkbox has been selected by calling the method isSelected, which returns a Boolean value, true if it's selected, false if it's not. So let's see how that works if we run it. Right. In this case, here is our test button. It says warp bubble creating. And notice I can select and unselect it. Collapsing warp bubble. I'll unselect it. Augmenting. Warp bubble augmenting. Warp bubble diminishing. Now, because I didn't add these to a button group, and they're checkboxes, not radio buttons, notice that if I want to, I can do 2 at a time. In which case, if I were to click test, it's going to go down the list and my event handler function ActionPerformed and simply do the last one. So if both augment and diminished are selected, then the final result after it sets the text to warp bubble augmenting will be warp bubble diminishing. And notice that's what happens, even though I have augmented selected. Only if I were to uncheck that would it say augmenting. So you can observe or see the differences in behavior. And notice also, again, because I added ActionListener to this checkbox here, collapse, and if I click on it, it fires off the JAptionPane every time I click it. Okay. So subtle differences there with checkboxes and JRadioButtons, but you can see how they work or how they behave in code. Here's an example of adding a JCheckBox in the NetBeans IDE. So under Swing Controls, I would select the checkbox and just drag it onto the form. And then I could add another button, and if I wanted to, I could add ActionListener to it just by right-clicking on Events. Notice it would code it. And then I could use isSelected like we did in the previous example if that checkbox were selected, or do something, whatever I want to do based on that event. Pretty straightforward. Here's just some different interfaces that would make use of these JRadioButton, JButton, and JCheckBox components. In this case, toggling between view and nav and navigation mode for checkboxes, and JButtons and JRadioButtons down here for weapon selection. Same thing over here, something similar, just with JButtons and JRadioButtons, and then here in a blackjack game. So just to give you an idea of where you might use these in an interface. Because it's related to the previous components, the next component we'll look at is ImageIcon. You can make your JButtons and JLabels more intricate by adding an ImageIcon to them. Using ImageIcons, you can create sophisticated graphics in GIMP or Photoshop, and then apply these graphics to your buttons and labels. This removes the limitations and constraints of using simple background and foreground colors, although doing this for each component can significantly increase your project's development time. Here's an example in code of using an ImageIcon. I'm importing the same three packages: Swing, Abstract Windows Toolkit, and AWT Event for implementing ActionListener. It's a JAPPLET. I have two JLabels and a JButton. And what we're going to do is apply the ImageIcon to the JButton to make it a little bit fancier button than just plain old RGB color values. To do this, I have to instantiate or build an ImageIcon, and I have to supply the path to a JPEG or GIF or PNG file. And because I'm going to compress it inside of a jar archive, I'm going to use the method getClass and getResource to get the code base or the class and then pull it from the jar file, the compressed jar archive. And once I do that, then I'm going to use the method setIcon on the button. I'm going to apply the ImageIcon to the button. That'll kind of give us a fancy button. And I'm also adding ActionListener to it. And when I click the button, it's just going to simply change the text on that JLabel device. Notice the structure here, the path. In this case, in my source folder, it's in a subdirectory called images. So I have to tell it that. I have to tell it go into the subdirectory images and then retrieve pirate JPG. So let's see how that looks. And you can see, in this case, here's the button. There's our ImageIcon applied to the JButton. And if we click it, here's the event handler. The next Swing component we're going to take a look at is the JComboBox. JComboBox objects are drop-down lists of options that can be placed on a JFrame and JApplet form, dialogues, and graphical interfaces. Some useful methods for JComboBox are remove all items, which removes all items from the combo box list, add item, which adds an item to the combo box, get selected item, which returns the selected item as an object, which you can then convert to a string, and then to string, which is not from JComboBox, but used with get selected item to convert the object to a string. Here's the example in code, and in this example we're importing from three packages: Swing, Abstract Windows Toolkit, and AWT Event, which will allow us to implement our event handling interface ActionListener. Notice we're extending JApplet, implementing ActionListener. In globals, we have two JLabels, a JButton, and we're instantiating a JComboBox as global objects. Inside the JApplet's built-in init function, as is required, we have to call getContentPane and assign that to a container object called BG. We'll set the layout to null, which means we have to use setBounds to set the x, y, width, and height of each component. We're going to add ActionListener to our JButton, so it'll listen for action events, and then we can handle them in action performed. We're going to add our label. Here we're going to add some string items to our combo box. So we're just calling the function addItem for 0-point manipulation, teleportation, telepathy, telekinesis, pyrokinesis, time shift, and gravity bending. Here we're going to add the combo box, again using setBounds to set the x, the y, the width, and the height. Now we're going to add, in this case, our JButton, and use setBounds again to position it and size it. And we're going to add our labels. Now let's look at the event handler method ActionPerform, which takes an action event. We're going to call the function getSource to figure out what item got clicked. In this case, it's returned as an object. Well, we can't really do anything with the object until we first convert it to a string. Alright, so if it happens to be the JButton, we're going to get the selected item. Again, it's returned to us as an object. Now we have to take that object, we have to convert that object to a string using the toString method. Once we do that, we can plug it into our if statements, and then based on whatever was selected in the combo box, we'll do something different with that particular JLabel. So again, object is very useful when you need just a generic object. In this case here, we're getting the source of whatever button might have been clicked, and in this case here, we're getting whatever item might be selected in the combo box. Either way, just remember we have to convert it to a string before we can pass it into F and make a decision with it using the equals method in this example. So let's see how that works. We'll run it. Alright, here's the JAPPLET background. Notice the default, in this case 0-point manipulation. I'll choose time shift or gravity bending. I click the J button and notice that it sets the text of the JLabel accordingly. Click it again with a different item selected and a different item. Notice each time it's changing the text value of our JLabel. So just an example of how that works in code. Here's an example of using the NetBeans Integrated Development Environment Graphical Design tool to do the same thing. So in this case, under Swing Controls, I want to select the combo box. I'll drag and drop it into the GUI Form Design tool. And notice the properties I can set here, all the different properties, and I can change the variable name if I want. I call that combo 1 maybe. And then here, I can look at properties, and if I wanted to set the items, alright, just add a couple items in there. And if I did that, if I were to compile and run the project, here's what that would look like. So essentially, the same thing that we did in the previous example, but we're using a graphical tool, NetBeans, to add it, and it's writing a good portion of the code for us. In other words, here's, it's declaring the combo box, and then if we're to go into init components, here it is adding those items. Here's an example of a combo box in a game, and in this case, this is just for different abilities. Okay, and I can select a different ability, and the code for that. Let's go look at the code real quick. Code for that is right here. And under display abilities, I'm simply calling remove all items, which will clear the combo box. And then I have some booleans here. And if I've gained a certain ability by facing an opponent, then it's just going to add that to the combo box. And I can select the object and then make use of it. Here's another example of an RPG game interface. And in this case, I have a combo box here for abilities. And if you look at the code for it, here in the code, I'm removing all items whenever I call the show abilities function. And that clears everything in the combo box. And then I have these booleans here. And based on whether or not I've acquired that ability, it's just going to use add item and add it to the combo box. Okay. So I have a cheat method, or a cheat function. I just put on a button here while I'm kind of testing and developing the game. And all I have to do is click it, and it'll simply give me all the items. So you can see I don't have any items because all these booleans are set to false. So let me go over here and click on the cheat button. Little JActionPane pops up cheater, and then it fills the JList object and also the JComboBox. But notice now I have all the abilities. And that's because these booleans are true now, and it called show abilities, and it just added them into the combo box after clearing it out. And then in addition to displaying the abilities, using add item to add them in as strings, I've also got to code a method or function that can get the selected value from the combo box so that I can use an ability. And that's down here, use abilities. And in this case, when I use an ability, I have to get the selected item, which is returned as an object. It comes in as an object, so what I want to do is I want to use the function or method toString to convert it to a string. And then I simply have to test for it using if and the equals function to see if it matches a certain string. Now I also had to use the substring method here in addition to toString because I have to peel off the numbers. In this case, notice if you notice, I'm numbering them 1, 2, 3, 4, 5, 6, 7. And so I have to peel off those first 3 characters, the 1, the period, and the space there. And that's why you see this function substring.3. If it weren't for that, if I weren't adding the numbers, then I wouldn't need to call the substring method at all. But I don't want to worry about what number it's added as, because that could change based on the order that they acquire certain abilities in the game. So simply because of using those numbers or indexing it with a number, I have to peel off the first 3 characters. But the 2 important methods, the 2 important functions are getSelectedItem, which returns an object, and toString, which converts it to a string, and then the equals function here, so I can just use an if statement. If shapeshift, here's what I'm going to do. And it depends on where they are in the game and what they're trying to use shapeshift for. And it costs them something in terms of energy. Okay. On the other hand, if it's time shift or regenerate or electromagnetism or gravity bend, I'm not doing much now. But as I continue to develop the game and code it, I would just put my code in here in each of these if blocks for things like sound effects, video sequences, images, changing coefficients and point values in the game, and so forth. So you can get an idea of how to both populate a JComboBox with items, and also then how to get the selected item and make a decision on it and do something with it. And again, if we were to look at that in action here, let's go here and let's see, I will space shift, and I'm just going to click on usability. Summons the power to space shift. That's all, gravity bend. Summons the power to gravity bend. And let's see, I'll do shapeshift. And here, just plays a sound effect. Shrink myself down to the size of a mouse. Notice my size changed here. And then it's Boolean, like a light switch. So if I do it again, notice my size goes back up to 10. And that's how you can get in and out of different places in the game. But it does cost you energy, points of energy and things like that, whatever. But you can kind of get an idea of how the combo box works. The next component we'll take a look at is the JList object, which is sort of like the JComboBox object, but instead of having a drop-down list of selectable items, the selectable items are displayed in plain view in a box. JList objects are lists of options that can be placed on JFrame and JAPPLET forms, dialogues, and graphical interfaces. Some useful methods for JList objects are remove all items, which removes all items from the JList object, set list data, which adds an array of type string to the JList. These are the selectable options. Set selected index, which selects an item in the JList, get selected value, which gets the selected object in a JList, and toString, which is not from JList, but it's used with get selected value to convert the object to a string. Here's the first of 2 examples in code, and we're importing the same 3 packages we always import: Swing, Abstract Windows Toolkit, and AWT Event for our event handling interfaces. We're implementing ActionListener and extending JApplet, and in this example, we're going to use a JButton. We'll add ActionListener to it, and when we click the JButton, we'll get the selected item from the JList. So the globals, or the objects we need, are some JLabels, a JButton for use inventory, and of course a JList object. And then the way we populate the options on the list box is with an array of type string. So in this case, these will become the selectable objects in the JList object: Master Sword, Clawshot, Goddess Bow, Beetle, and Slingshot. Inside the init method, which is called automatically, we get the content pane and assign it to a new container object. We set the layout to be null, so we have to use setBounds to position the x, y, width, and height of each item that we add. And then we're going to simply add our labels, and then we're going to, in this case, set all of the options on our JList object, right? Inventory was our string of selectable options. JLinventory was our JList object, so we're calling setListData right here to set that array of type string to set all of the selectable items on the box. And then we're going to set the selected item to the very first one. Alright, so in this case, index or subscript value 0. So we'll select the very first item up at the top, which is going to be what? In this case, Master Sword. Once we do that, we're going to add that to our JApplet. And then we're going to add our button. And then we're going to add status. Well, what we're going to listen for, what we've done is we've added ActionListener in this example to the JButton. Okay, so the event will be clicking that JButton. And in the event handler function, ActionPerformed, the action event that will get triggered if the source happens to be our JButton, then we're going to get the selected value, okay, get selected value here. that's returned as an object. And as we did with the combo box, we need to convert it to a string. So once we get it and return it as an object, here we're going to convert it to a string. We just want to make sure that it's not null. Once we convert it to a string, we can then use the equals method to match any of the strings, the selectable values that we added to the JList object. And based on that, we're going to do something different with our JLabel. So let's test it. We'll run it and see what it looks like and what happens. Alright, so here is our JApplet interface. Here's our selectable items. And if I click the J button, use inventory, equipping the master sword. I'll select a different item, click the button, firing the claw shot. Goddess bow, selecting the goddess bow, flying the beetle, using the slingshot. So you can see how that works. Now, here is another example in code, and we're going to use a different event this time. We're importing the same three packages and extending JApplet, but this time, instead of implementing ActionListener, we're going to implement FocusListener. And instead of clicking on a J button, we'll actually just click on the JList object itself, and whenever it receives the focus, that'll trigger an event, and it'll go and find the selected item and trigger the event or handle the event. So the same two JLabels, the same JList item, the same array of strings, in this case our options that we'll add to the JList, but this time instead of adding ActionListener to a J button, there is no J button, and we're adding FocusListener to the JList object itself. Okay, so we add FocusListener, and we add all our items in, and again here we're using setListData to populate our JList with our array of type string up here, all of our options. And once we do that, we're setting the first item to be selected, again in this case the master sword. But because we're implementing FocusListener right here, and because we added FocusListener and not ActionListener, we have to handle it a little bit differently. So instead of action performed, our event handler is focus gained. Okay, and also we have to include focus lost even though we're not using it because it's abstract. It's in the interface, and remember when we implement an interface, even if we don't use the method or function, we have to code it and override it inside of our class. Okay, so focus gained is what we're going to make use of. And it'll come into us as a focus event, that parameter, that argument. So what are we going to do? The same thing we did with action performed. We're going to get the selected value. It's returned as an object. We're going to convert it to a string. And once we convert it to a string, we're going to use the equals method to see what is selected. The only difference in this is that the behavior, instead of having to click a J button, all we have to do is click the JList, and once it receives focus, it'll perform the selected option. So to test that out, again, notice that it looks like the previous example, except we don't have the J button. And the event handler, the event listener, and the interface are different. So in this example, when I change the focus, watch what happens. And then as I select each item, it changes the text of the JLabel. So just two different methods, two different events, two different interfaces of using ways of using a JList object. Here's another example in a game project, and in this case, I'm using a JList object for inventory. Remember, abilities was a combo box, but in this case, a JList object is used for inventory. I haven't found any items yet, so it's blank or it's empty. Now let's look at the code for that. In the code for that, I have a method called displayInventory, and it uses an array of type string and some booleans. Based on whether or not they're true or false, I'll simply add them to the array of type string. Now, every time I call this method, I'm instantiating or rebuilding this object, this array of type string. So it'll always start out as blank, and that way if I acquire or lose certain items, inventory items, then those changes will be reflected accordingly. And I simply use if statements and the booleans, and if I find the item, I'll go ahead and add that to the array of type string. When I get done constructing the array and adding the items to it, I'm going to add the whole thing to the list box with the method setListData. And then these items down here, these statements don't really have anything to do with the list box. They're just JLabels that I'm setting for things like ammunition and money. But as far as the JList object itself, the methods we're interested in are setListData for adding the items, and then of course the array of type string, which is what we're adding to it when we call the method setListData. So to see that in action, I'm going to go ahead and walk down here, and I have a cheat method. If I put a tilde in this location, in the south 1 location, a fairy appears and gives you godlike powers. Cheater! But notice that it added all of those items now to my inventory. So you can see the JList object has been populated, and it's been populated with all of these values here, since all of these booleans were set to be true, or in this case, for things like med kits and Glock ammo, they're integer amounts, but since they're no longer 0, they're greater than 0, then they were added into the array of type string, which then got added to the JList object. And in this case, we refreshed it, and it displayed those items in the JList here. Now, what if I use an item? What happens if I use an item? If I select just a random item here, let me select one of these items, and I'll do use. And now hold in my hand key 1 access key. Jackknife, okay, sword. Select that item, Sword of Omens, ha 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 ha. Yeah, but Glock here. I'll put the armor on. Put on the armor, okay, and then select armor again, and then I take off the armor. It's just boolean on and off like a light switch, and you notice my defense increases, and then notice my defense decreases if I do that. Whatever you want to do with that. I'll use a med kit. I use a med kit as 25 to help, and I'll use another med kit. All right, and as I do that, in this case, as I use the item, it's the display inventory function is updating my JList. I had 100 and then 99, 98, 97 med kits and so forth. Whatever I use from the inventory. When I use an inventory item, the code for that I've placed inside the event handler function, the action perform method for our JButton, the use button. So they select the item from the JList box, and then they click the use button to use it. And this is sort of similar to the way we handled things with the combo box. We call getSelectedValue, and that returns an object. And then we have to convert the object to a string using the toString method. We just want to check and make sure that it's not null, that they have something valid selected. Once we do that, I could have used the equals method to compare the string, but the problem is, if you look, I have numbers here in the JList object data. And so that would be like 4 characters that, I basically wouldn't be able to just say equals armor, because I'd have 1, 0, period, space, and then armor. So the way to handle that, remember previously we used a substring method. I could peel off those characters with substring, but another way I could handle that in the code is I could simply use the contains method. And the contains method doesn't require an exact match. It just looks through the whole string and says, well, regardless of whatever other characters may be in the string, if it happens to have these characters in sequence, key 2, key 1, whatever it might be, whatever other inventory item, jackknife, regardless of all the other characters that come before or after, then that would be considered a match. So here's just another example or a way to code things using the contains method instead, if you chose to do something like that with your JList object. And I'm just going through and saying, look, if it contains that string data, I'm going to do something different. I'll play a different sound effect. I'll affect something, be it health or hit points if they use a med kit, or their defense stats if they decide to wear their armor, put the armor on, things like that. Here's just another quick example, and I'm using a JList object. Notice I have nothing there yet, no items yet, and if you look at the code for that, let me collapse this little box down here so you can see. Just like the previous method, I'm using these booleans or integer quantity items, and either true and false, true they have it, false they don't, or if it's greater than 0, a quantity item. And then if they don't have anything, it says no items yet. And that's why it says no items yet. But if they find these things or these items, and I call the method, in this case, show inventory, it's just going to add them in one by one to my array of type string. And then I'm going to take that array of type string and set all of the options in the JList control with setListData. So I have a cheat function. Let's call it and see what happens. Cheater, all those items are then set to true. So all the booleans are set to true, and all the quantity amounts are now greater than 0. And again, let's look at how we would use those items. Okay, and let me scroll over here, and we'll go to the function in the navigator pane, use inventory. Just like before, I'm calling getSelectedValue. It comes in as an object. I'm converting it to a string, and in this example, instead of contains, I'm going to use equals, and I'm going to use the substring method to peel off the number and the decimal and the period and the space there. So the first 3 characters. This wouldn't be necessary if you weren't indexing them with numbers or characters that you weren't looking for. So again, I could use the contains method, or here I'll use the equals method and substring. Either way, I'm just going to detect which item is selected, and then based on that we'll do something different. Play a different sound effect, do something with armor or health, or some other attribute of the character object in the game. And so to test that out, again, let's see how it works. Bring up the interface here. And when we do this, let's go ahead and we'll pick a couple of items here. Notice that in this case on my interface, this changes to stab. I'll select the sword, changes to slash, the Glock. Okay, power staff, a grenade. I'll toss a grenade. Notice that the quantity item is decreased. Here's an example of adding a JList object using the NetBeans GUI design tool. Look how easy that is. We just drag and drop it on there. I'm going to select it, highlight it, give it focus, and then we can add the items to it we wish to add. Let me go here and let's say I'll just add some items in there. And you can see how it just graphically added those items to my JList object, and it writes the code for you. Comes down here, and here's my JList object, and then if I were to go into the generated code, you could see it setting the attributes and properties on the items. In this case, it just builds the array of type string and then sets it.